Hello everyone, welcome to Cyrix Digital Academy's Basics of Blockchain and Cryptocurrency course, and we are going to be focusing on Bitcoin, the first implementation of the blockchain technology. We are going to be seeing how the Bitcoin system or ecosystem works. We are going to be looking at some key things that you've been probably trying to know how they work in the crypto space. I would suggest you start from the first video in this um, playlist so you can get lots of understanding of what we've been talking about so far in this course. So first of all, our focus is going to be on the features of Bitcoin, the Bitcoin white paper. You've probably heard of it. You've probably heard about the Bitcoin white paper, and you are, how does this really work? You heard about crypto and fiat and Bitcoin and blockchain. All these terms are things you would want to understand them, and you don't really have someone to lead you to that, or probably you don't really get to understand the terms people are using to explain this to you. Well, we've brought it down to simplified terms, and this video is to help you understand Bitcoin and blockchain in the most simplified manner. So just stay glued and let's get started. So first of all, Bitcoin is the first implementation of the blockchain technology. Yeah, because remember we talked about in the first video in this course, we talked about Bitcoin and we talked about the blockchain. We talked about how the blockchain work. We were dealing mostly about on the blockchain. We talked about the features of the blockchain, the types of blockchain we have, and we also looked at where blockchain technology is being applied. We saw that remittance is also one of the key ways, one of the key places or key um, let's say, yeah, key places where blockchain is being used. So we are going to be looking at how Bitcoin comes into play in that case of remittance in the blockchain technology. So first of all, we have that blockchain, the Bitcoin is decentralized. It's a digital currency. There is no physical Bitcoin. There is no physical Bitcoin. Bitcoin are held in digital wallets. Bitcoin uses digital signature, private key to allow people to send or to authorize spending of Bitcoin. So if you own your Bitcoin, you need your private key for you to access it and for you to spend it. Bitcoin uses a distributed public ledger. We remember that's one of the features of the blockchain technology. Bitcoin uses low fees compared to your traditional banking. If you are to maybe send money from one country to another, you would notice that first of all it will take long for that to happen, having to move, we are talking about hard cash here, or probably even bank transfers, or um any kind of transfers you can possibly do. This is something that takes long. If it doesn't take long, it comes at a huge fee because of exchange rates, slippage, and all those things. They change very, very often, and so people keep these rates very, very high. Banks keep these rates high, and these fees are usually high. So Bitcoin covers cheaper fees for that. We also have that the Bitcoin white paper was released in 2009 by Satoshi Nakamoto, and Bitcoin has a limited supply of 21 million Bitcoin. So it in the whole of the universe there is only going to be 21 million Bitcoin. Once it is exhausted, there will be no Bitcoin added to circulating supply again. Okay, that is going to be the total Bitcoin we are going to have. Now, Bitcoin was launched in 2009. Bitcoin is the world's largest cryptocurrency by market capitalization, and by market capitalization we mean by money invested in it. Okay, so Bitcoin is the highest cryptocurrency that has money the most. Okay, I believe that's clear. So unlike fiat currency, Bitcoin is created, distributed, traded, and stored with the use of a decentralized ledger system known as the blockchain. You see, so the Bitcoin is on the blockchain. You might be asking what is the difference between Bitcoin and blockchain. You might hear Bitcoin blockchain. You are like, oh, is it not more like kind of a repetitive thing? No, the Bitcoin is a cryptocurrency. The blockchain is the technology that supports this cryptocurrency. Bitcoin is built on the blockchain technology. Okay, so that's just one thing you have to get yourself clarified on. So it's just like saying your bank app and the internet. Okay, your bank app is built on the internet. Okay, because it's the internet that enables your bank app to be functionable. So the Bitcoin is what? The bank app, while what? Blockchain is the internet of Bitcoin. So Bitcoin is built on what? The blockchain. I believe that is clear. Then Bitcoin's history as a store of value has been turbulent. It has gone through several cycles of boom and bust. Bitcoin has actually gone from very low in price. It was as low as $1 or less when it was first created, but it's boomed to what we have as the current price now as of the time you're watching this video. So Bitcoin has been growing, it has been growing, it has been falling. You hear the rise and fall of the coin because of the loss of demand and supply on it. So as the easiest virtual currency to meet widespread and popularity and success, Bitcoin has inspired a host lot of other cryptocurrencies. So you might see of other cryptocurrencies like Ethereum, Ripple, you might hear of BNB, you might hear of Litecoin, you might hear of Dogecoin, you might hear of every other thing like that. So all these things are still cryptocurrency, and they are still doing what? They are still working on the technology that is known as the blockchain technology. So all of them are using the same framework, the same thing. Okay, the blockchain is what enables them to be called cryptocurrency at first, because that's the whole essence of the blockchain. So first of all, we are going to look at the Bitcoin white paper. Remember, I promised we are going to look at that. So because probably lots of people have been saying, I don't really understand what's happening on this paper. Probably you've tried reading the Bitcoin white paper, you don't really get understanding of it. We are going to break the Bitcoin white paper into bits as it is. First of all, let's head on to the Bitcoin white paper, and you can find that in bitcoin.org. So I'm just going to go ahead and type bitcoin.org. I see I already have it here, so I'm just gonna do this. But in case you want to know exactly how to navigate, we are going to place this link on the description of this video so you can make use of that. Now please note that depending on your country, you might need to use VPN to access it because of some jurisdictions on the Bitcoin white paper that has been going on recently. So you might not be able to access the Bitcoin white paper on some this thing. You might have to use a domain, and especially for the UK, you might have to use the VPN for you to access it. So this is where you can see the introduction. You click here, you can see the white paper, and then you can view the English original or any language you would love to view. So this is basically the Bitcoin white paper, and we are going to break this down in bits. First of all, the Bitcoin white paper, we know that it's written by Satoshi Nakamoto. Now this can be a person, this can be groups of person. We don't know who this is. This is a pseudonymous name, and it is charged with the creation of the Bitcoin blockchain. Okay, so basically the abstract explains how what you'd see in this paper and what this Bitcoin blockchain is coming to solve. Now Bitcoin is not actually the first currencies, the first digital currencies. I won't call them cryptocurrencies because the previous ones, they probably did not harness that blockchain feature, so they were just digital currencies. Now what enables Bitcoin different from them, what this Bitcoin came to solve, was the problems that the other digital currencies were not able to solve, which is the problem of double spending. Okay, and we are going to explain double spending, what that means. Okay, for example, you go to a store to purchase an item. First of all, you take out your debit card, you get the item you want, and you slot in your card on the device of that store, and you are being charged, and your transaction is successful. That's a simple way that works. Now, the money you just spent is a digital form of money. It's not a cash form of money, because if it were hard cash is not something you can easily fake or something. So if it was hard cash, it's easier for you to tell, okay, this is the accepted one from the government by certain quality that are placed on the bank notes. So it's easier for you to detect. But when it comes to digital, you can easily fake anything on the digital. You can fake balances and all those kind of things and do so. That was one of the issue digital currencies had back then. They couldn't solve it. So that is a problem of double spending, because if I have $50 of a digital cash, what stops me from making that $50 into $1,000? I mean, it's digital. All I have to go is change the values and then I have more of it. Okay, what stops me from doing that is because of this problem that has been solved by the Bitcoin blockchain of double spending. Okay, that's what cryptocurrency has been able to solve. But with other digital currencies that existed before Bitcoin, you see that they couldn't solve this problem. The problem of double spending was the issue, because people could easily make that, and there was no way to stop double spending, because the only way double spending is prevented through your bank card is because your bank is there to verify that yes, this guy has $50 or $50 in his account. So if I try adding more zeros to my $50 to make it $50,000 or $5 million, you see, it's definitely going to change the whole story. It's going to change the whole thing, because my bank is going to tell the store, this guy has only $50, you can't charge him, so this transaction is rejected, and by so doing I won't be able to get anything out of the store. So that is how double spending is solved in the centralized manner. Now Bitcoin wants to solve this by not allowing anyone to be in charge of verifying this transaction. They don't want any bank, they don't want any central authority, they don't want anybody to be responsible for approving or verifying that yes, this guy has only $50 in his account. So the Bitcoin came into place to solve that using a peer-to-peer cash electronic system. Okay, so now let's go into the introduction. The introduction further explain what I've been saying, and you can see here, if you read through all this yourself, you can get basic understanding. So now the introduction further explains that transactions are going to be non-reversible. You can see here, which is one of the features of blockchain. Nothing can be changed, nothing can be reversed in it. So if someone mistakenly sends you Bitcoin, you have to be the one to send it back. You can't click on a button and then reverse the transaction. Just unlike the store, if I take my card to the store and I was due to technical issues, I was mistakenly debited from my card, but I didn't get what I can easily request my bank to get a refund to reverse that transaction, and my bank just has to click one button and that is done. It's very, very easy. But in the Bitcoin, no, there's no button for you to click to reverse transaction. I have to be the one to send back your money to you if you mistakenly send it to me. So that's one thing about the Bitcoin blockchain, or the blockchain entirely, that you need to know. That's one of the features of a blockchain. Okay, and the Bitcoin blockchain also says it to be using a cryptographic proof that does not trust any third party. I'm going to come into that so you understand what it means by a cryptographic proof, because I'm sure these terms are quite new to you, and you would want to really get it really broken down for easy understanding. So non-reversible transaction, non-changing transaction, you can't edit anything because of what the blockchain supports it. So anything that comes on it is actually honest. So everything that is on the blockchain is secured by everyone on the network. We'll talk about those who are the participants on the network and how all the transactions and everything work. Okay, so now the next thing goes into the transactions. Satoshi Nakamoto talked about the transactions, how transactions will be taking place on the Bitcoin blockchain, how things will be going on there, and let's just see how that was done. So after the introduction, he made that known of how transaction is going to be working on the Bitcoin blockchain, which you can see here, honors and honor 2, honor 3, all these are basically things that are going to definitely confuse you, but yes, as I said earlier, we are going to break this all down. Now forget about all this you've seen here for now. Just picture this in mind, okay, of how transaction work. Okay, each owner can transfer a coin from one person to another by signing with his private key. If you want to send money to another person, what do you need to do? You need to input your bank card pin, or you need to input your bank pin, okay, for you to authorize transaction to be sent. Okay, that is how transactions work on the Bitcoin blockchain. Now there are more things to it. So now let's go back to the old model, the traditional way the banking system works. We understand that if transactions are to take place, the bank verifies the transaction, that yes, you have this money and this is the only amount of money you want to spend. Now in the Bitcoin blockchain, we want to take out that third party. We don't want that third party to be there, but we still want to be able to verify transactions and verify that there is no double spending. So in order to do that, Bitcoin blockchain sets up certain ways in which to manage that. One of the ways is that the Bitcoin blockchain only considers the transaction that comes first as the original transaction. So let's say you have $50 and you sent me $50 and you sent another person $50. Now the first transaction you made, which was to me, is the one that is going to be the legitimate transaction. The second one, it's not, is going to be the counterfeit transaction. Now this is done by a timestamp kind of mechanism, which enables and ensures that this transaction came in first and this one came in second. We'll come into that, to knowing how does the whole network, how does the Bitcoin blockchain tell that okay, this transaction came in first or this transaction came in last, okay, or came in later. Okay, so that is where the timestamp saver comes in. The timestamp saver ensures that it takes note of a transaction when it comes in and when it is being broadcasted. So first of all, for us to verify that a transaction is legitimate, we have to know when the transaction came in. And how do we know? Who is responsible for knowing the transaction that came in? Who is in charge of this? Remember, we want to take out the bank, we want to take out a third party, whatever third party, bank or whatever. We want to take out a third party. We don't want someone to be there in charge of saying yes, this transaction came in first, so credit this one, leave the other one, is a fake transaction, cancel that one. How do we do that? First, for us to do that, we must broadcast the transaction to everybody. We must broadcast the transaction to everyone in the network, and the timestamp saver is responsible for telling when a transaction came in and recording it and broadcasting it to everyone. So the timestamp saver tells the whole network, everyone, when this transaction came in, and we know okay, this is the one that is legitimate or this is the one that is not. Now the next question comes in: who is everyone? Who is everyone in the Bitcoin blockchain? You've not told us how the whole stuff works, the whole verification to stop the double spending work. Who is everyone? So let's get to know who the everyone of the Bitcoin blockchain is. First of all, I would like to, before I continue, I would like to say you don't have to overthink the timestamp saver much. It consists of layers of encryption and cryptographic proof, which is a lot of stuff for you to take in. But in the course of this video, as before we get to the end, you get to totally understand how everything works in synchronization. Now remember that Bitcoin is made on a distributed public ledger. Now the problem we want to understand now is how does it work? How is it that we ensure that the hash, or sorry, we ensure that the ledger is not actually duplicated in the course of transactions coming in to the blockchain network? How do we ensure that it's not duplicated? Yes, for you to do that, you have to understand the hash. The first word I said there, you have to understand what the hash means. Now if you read through the whole of this, we won't explain what a hash is, but I'm just going to look for a simple term to look for how I can make that make that for you to understand. First of all, a hash is can be compared to let's say a prepared meal. Okay, so let's say for you to prepare a meal, you have to first of all get the ingredients and add it up, and then there comes out the meal you are preparing. First of all, we know the ingredients we need, which are in this case we can call that the transactions, and then what is the meal? The meal either is actually the hash. So the hash is what the completed action that we are looking for, is the output we are looking for, while the ingredient is the transaction that are coming in on the blockchain. What that is the content on the ledgers which we want to verify that they are unique. Okay, so first of all, once these things are created, once for you to make the meal, you have to first of all get the ingredients. And once you have processed your food, once your meal is made, you can't go back from meal back to, okay, let's just use a case like bread. Okay, you know bread can't turn back to dough, right? So once you add your dough, you know, give all the tons, the eggs, everything you want to do, once you turn it to bread, it can't go back to dough. So that's basically how a hash works. That is what a hash is all about. Now the Bitcoin blockchain works like similar things. So now first of all, the transactions will come in form of the dough, and they would be turned into the bread, which is the hash. Now first of all, the hash will come out in a way, a way that is more like let's say 657, something like that, similar to that. But you would see that it doesn't have the required 0 bits, which is what is required for the Bitcoin network. The Bitcoin network also added here that the block hash needs to have some levels of 0 bits. What does this mean? It means that the first numbers that of the hash is a 256 hash. So the hash must have some levels of some numbers of zeros at the beginning of it. Okay, some numbers of zeros at the beginning of it. If it doesn't have that, it won't be added to the block. Okay, so how do we ensure that that happens? Because on default, when you add transactions, it is always going to give you something that is not having that required number of 0 bits, and we are going to take a look at it in a practical examples of how it works. So to do that, we are going to head on to this hash demo quickly as we see how that works. We're going to do hash demo. You can see this is, we are just going to use the second one. We now go to blockchain. Okay, now this is the first block. You know, we want to add block. You can see this already has the required. Have you seen this? This already has the required now. Now we need to put in data. We need, this is the transaction coming in. This is the transaction coming in. We call this transaction 1. We call this transaction 2. We call this transaction 3. Okay, now you see that this is, everything here is red because data has changed, and you know everything is no longer remember one of the rules of the blockchain is that once the data is changed in the previous block, you have to, you know, make sure that data varies throughout the next blocks. Okay, the previous hash, everything should synchronize, but you see this previous hash and this, they don't really match, and they are not mined. Okay, so that can cause the transaction to, you know, to the blocks to be rejected if that block is to be edited. That is why the Bitcoin blockchain is the blockchain is secured in that aspect, because for you to change anything in a previous block is very, very difficult, because you have to keep on doing that and maintain 51% of the network control. You have to be in control of creating 51% of the Bitcoin or of the blockchain. Sorry. So now we can see here, this is a hash. This is how typically the hash looks like. You can see this is how it looks like. Now we want to make this do what? Hash required 0 bits. What do? We mine. Okay, Now the mining is actually the proof of work. The proof of work. Now, because you can't just put in the data. If it is just putting in the data, it means that someone can simply try and guess the data exactly, but by adding this 0 bit, it now creates extra security. It's now an extra security step, okay, that this thing must have some level of zeros to it, which comes into the mining, and the mining process starts. You see, I click on the mining and the mining takes place, okay, and there is level of duration that the mining that this mining prevents. You can see this mining doesn't happen automatically, because this is done to prevent people coming into a deep data and do everything fast and get out of the network without being noticed. So all these are security steps for the blockchain technology. You can see now we have 1 2 3 4. Now this is the required 0. It can be more than that, it can be more than that, okay. Now this has made the required 0 bit that for this hash to be added to what the next block. Now once it is added, we have to do another block here. We put another transactions like that. We put in data transaction, whatever it is. Blockchain can record anyone, and we do what? We mine again. We must get that required hash for it to be added, or for this block to be successfully created. See how that goes. So basically that is what this proof of work explains, okay, that you must go into that work. That if you've heard of the word mining, you've heard of the word cryptocurrency mining, basically this is where it comes from. The process of mining, if someone says he's mining, this is exactly what he's doing. He's doing what? He's digging, finding, because how do you get this? You don't just click a button and this is done by a computerized calculation or anything. This is actually done by computerized calculations, okay, because if it were to be done by humans, it would be quite slower. So the miner is actually a computer that is responsible for doing what? For guessing things that he can put into this data that has been provided. Is guessing things that you can be put into this data that has been provided, so that it can give us what? The required 0 bit. And this data, these things that they are adding, doesn't come to this data field, okay, because it would be recording a different data entirely. Where does it go? It goes into the nonce. Those things that are added are known as the nonce. If I change this now, you see it is red, okay, meaning that block has not satisfied. But if I add the 6 back, that is just what it needed. So for this to be acquired, the nonce must be guessed, okay. It's a very big guessing game. So the nonce must be guessed, which is known as the mining process. So when you hear someone say he's mining, this is basically what he's talking about. He's trying to find the correct nonce that matches the correct matches this data that is added here. Now you can see here that this data, if I add in this same nonce is maintained here, but you see it doesn't match, and I can't really do that by guessing, because it can happen anyhow, and I don't know. But if I add probably the 6 there, you see everything is back to normal. So that is what it needed, okay. This nonce is the exact nonce that is needed for me to generate this hash. So basically that is what this proof of work talks about. Now we go into the network, the everybody of the blockchain I was talking about earlier. But now remember, before I continue that in my explanation I mentioned about bread and some other things, and converting it, and you might be wondering how that happens, okay. Well, all these are not done by any calculations. They are done through cryptographic calculations, and it is broadcasted throughout the whole network with the timestamp saver. So once the timestamp does its work by recording when this data is coming in, the proof of work takes the data, adds it, and then tries to find what the right nonce that is going to give a output that is going to make the block, that's going to help it have the required 0 bit that is going to make that block a successful block before moving to the next one. If one is not completed, we are not going to another one, we stay there. So that's basically how it is. So the network involves nodes, okay, which basically they are kind of, yes, the network of the Bitcoin blockchain basically works with the help of nodes, And basically you might be asking, who are the nodes? Who are those responsible for broadcasting of transaction? Because remember, in the first part of this video I was explaining that you have to first of all check if this transaction has been double spent, or if this transaction is genuine, is legit, and then if it is legit you allow it to be spent. So who are those that are responsible for verifying? Since it's everyone that is responsible for making this app, who are the everyone? It's basically the nodes, okay? And these nodes are basically computers, and these computers of course are operated by humans, and they are set to do that task. Who can join the node? Anybody can join the node. As I'm speaking to you, I can own a mine. You can own a mine. Anyone can own a mine, or can be a node in the Bitcoin blockchain, okay? And you verify transactions as well, okay? Now you might be asking, how does that happen? Okay, how does everyone be responsible for mining transaction, okay, in the blockchain? It's simple. Everyone, once a transaction comes into the network, everyone does what? They start looking for these nonce, okay? Everyone goes into work, they start looking for these nonce, this correct nonce that is going to give you the required 0 bits, okay, and produce the hash. Now once a node finds that answer, it broadcasts the information to every other node, okay? And once every other node check that this guy has actually found the answer, this is correct, because what would they do? They'll just have to copy these values and check it by themselves and see, yes, this is actually the correct answer. Once they've been able to know that, okay, this is correct answer, the other nodes agree to it. Now this is not done by human, of course. As I've said earlier, the nodes are computers, okay? And computers, they are strict in tax, okay? So they do exactly what is given to them. So basically they check if the transaction is genuine. Once that is done, they approve it, and once everyone agrees on it, or most number of people on the network agree to it, everybody would now leave and start doing another transaction. They will start verifying another transaction or another block. Now what happens when two people find the answer at the same time for some reason? Yes, the two answers are going to be allowed. The network is still going to be running with those two answers. But what is going to happen now in this case is that one of the network, or one of the answers, will have to maintain its chain. Remember, transactions are broadcasted in chains, okay? Transaction 1, transaction 2, like that. It keeps on forming chains, okay? So if the second person or the first person, or whoever the two people were, or three, that found the proof of work first, remember they are looking for the proof of work. So if they find the proof of work first, remember the next, they will run what? Simultaneously, okay? Now what happens to the other ones? Okay, the branch is going to become open until it is closed. When will this branch become closed? The longer branch is going to keep the network running, while the shorter branch is going to be closed, okay? That is basically what this is telling us, okay? So just like you are trying to trek a distance, and someone else is trying to trek the same distance with you, okay? Now if for some reasons you get tired and stop on the way, they will not record your own distance for you. They will record the distance of the person that keeps on going ahead. So that's basically what the blockchain does, okay? So once this can't catch up with the other one, the other one has a longer chain. Since the blockchain is more focused on keeping itself running and keeping a longer blockchain and continuously creating new blocks, it is going to go with the chain that is longer, and these other ones will have to agree and start matching up with the other block. So that is what makes this very, very difficult, and it needs a lot of computational power. You don't just do that with a $50 laptop probably, or a $100 laptop, or a cheap kind of. You have to have a lot of computational power to do that, because now there are so many people mining, and the more the miners, the more the people on the network, the more difficult it is, because everyone is trying to get the same answer. The faster they get it, the lesser your chance to have chance with small computer. So you have to have high computational power, and which needs electricity, very high amount of electricity. And you might be wondering, why would someone be interested in going to mine? What is my gain of becoming part of it? Well, it's you come to gain very, very big incentives, which is what the next paragraph talks about. Now the incentive is rewarded after each block is created. Once a block is successful, the person that found that perfect hash, a person that found this is going to be rewarded with some of the Bitcoin tokens, or Bitcoin tokens. Yeah, so you are going to get that as just like a gold miner. Okay, once a gold miner finds gold, he is rewarded with what? The gold. So once you find the answer, you are rewarded with what? Bitcoins. That's basically how the incentive works. So that's what I'll just talk about in this part. Now it further goes into explaining reclaiming disk space. You don't really need to know much about this, but if you want to really do, reclaiming disk space talks about how the Bitcoin blockchain will manage space, because the next thing that might come into your mind is, how does it manage all these transactions since it was created from 2009? How does it manage to keep all these transaction records and all these things? Well, it uses a form of a macro tree, which some transactions or some things that are not needed again are removed to save disk space, okay, and to enable transactions to still be done on the network. Okay, and you can see this transaction was done in olden computer speed and disk space. Okay, and you can see now that the disk space in computers are growing bigger. You can see it's still working. If this was made in the worst scenario, you can see now that we are having computers that can do better, the Bitcoin blockchain has higher chances of doing better in future. Okay, now this part of the blockchain of the Bitcoin white paper discusses or explains how transactions are done in form of a macro branch, which is what I explained here, which helps in saving disk space and all this. So transaction necessarily don't have to carry their own carry their own ledgers. Every transaction must have its own ledger, like that. So it just has to be a fraction of it, kind of, and the transaction would still be done. Okay, and if you go here to the Bitcoin, okay, if you go to the blockchain, you would see blockchain.com. You would see here we have, let's wait for that to load. We have the Explorer. We are going to go to the Explorer. You see how transaction basically work, to so they don't have to own their own ledger. So now you can see this is a hash. Let's open this. Yep, you can see in this hash. Okay, this only has one. So this is a typical example of this hash. You can see now this hash has this. It has not yet been added into a block. Okay, let's do this other one. Yes, this is what I was looking for. Now you can see there are numerous transactions inside this hash. Okay, so this is basically what that is trying to explain. Okay, so you don't have to come and explain one transaction goes and then a ledger is created just for that. So it just has to be a fraction of it. And we now have the next thing, combining and splitting values, which is another explanation which is made on this about. So combining and splitting values, it would be really a big problem if we have each transaction. As I've said, each transaction has to own its own ledger. It will be a very big problem, because you have to go through tedious searches to do. So a transaction can be called a transaction if it is one big spending, that is probably one Bitcoin, or very big spending, or multiple spending, or a transaction could be sending in and sending out. Okay, so let's say you are sending in and out from, let's say, a source or whatever on the blockchain. It can be seen as a transaction. That is why you can see this is a transaction for this hash, transaction hash. That doesn't mean that this is only for one transaction. You can see there are multiple other embedded into it, so it will be very hard if if transactions will just be having its own hash, you have too many things to record. So that is just one of the combining and splitting value, what that really means. And then we go into privacy. Privacy, you don't have to release your identity, unlike your banks. You have to verify. Sometimes you have to give more information that you even need. So this is better than the banking model, because everyone is anonymous until you tell someone that this is your wallet address. Nobody knows that this wallet address belongs to anyone. You can see everything here is represented in wallet address. No one, you don't see anybody's name here. This is address. You don't know who owns it. Okay, until the person says, I am the owner of this address, BC1Q, or this thing. So you don't know who owns an address or the blockchain. Okay, so privacy is one of the things it's secure. You can see we have extra calculations here. So this extra calculation basically is just, I think, satisfying all the conditions that I've been mentioning from number 1 of the white paper to number 10. Okay, it's basically telling them, okay, how it is difficult for someone to create his own Bitcoin, that is double spend, and then use it and double spend on the network. So it explains that if someone is to have that kind of power to do, he would rather spend that power in mining, that is become part of a node, than for him to become an attacker, because there's no profit becoming an attacker, because you'll be unsuccessful. But rather, if you use that kind of mining power, that kind of computational power to become a node in the network, you even have money more than most of the people. So trying to fight the network, which is something really, really difficult, rather than being honest. So it's better for you to be honest and get your paid, rather than spend money and you don't get paid and you lose both ways. So that's what that calculation part basically explains. You can see it goes into further details, and then the conclusion, of course, summarizes the whole of the white paper and explains the purpose, and also we have the references here, which references the content of this white paper and things it gets from. You can see the hash here, which I mentioned earlier that there were other digital coins. So Satoshi Nakamoto made references to all those where he got his ideas and all those things about the Bitcoin white paper. So that's basically it on the Bitcoin white paper, which was published again by Satoshi Nakamoto. Now let's go into another part of this video, which is crypto and fiat. What are the differences between crypto and fiat from what we've seen here so far? You can see that as the crypto space is, as the blockchain is this, you can see it is immutable, meaning no values can be changed. Fiat can be changed. The bank can choose to change whatever they do. They can choose to create money and add to the existing fiat that exists in the market. It can be double spend for crypto, but in case of fiat, you can't say that. You can't say that because fiat can't be double spent in cash, but in bank, this thing we also can't be double spent. So basically, the problem of double spent is not faced by fiat, but is faced by digital currencies that do not use the blockchain technology. So fiat actually kind of narrowly escapes that, putting the risk of centralization on you, which the reason people are running away from centralized monetary systems is because of political reasons, social reasons, having your freedom of speech without your accounts being blocked and all those kind of things. So that's basically why the double spend solution of fiat is not preferable to that is offered by crypto. Then we have easy to transport fiat. You can easily carry money around, except digital, which we still go back to what I just said earlier. So easy to store. Fiat is fairly easy to store because you have to ensure a third party to do the storing for you. Crypto has no physical office. There's no physical office you can go to acquire a crypto. But for fiat, yes, it has a central authority, and crypto is decentralized. Fiat is obviously very, very centralized. Then cryptocurrency is the most global medium of exchange. Yes, there is no country, we don't have cryptocurrency that we say this is Bitcoin, this is Bitcoin UK version, this is Bitcoin US version, this is Bitcoin Netherlands version, this is Bitcoin. You don't have that. But for fiat, yes, fiat is only works in the issuing country. You can't spend US dollar in UK, you can't spend UK pounds in US. So basically that is how that's one of the key differences between crypto and fiat. We also have easy person to person, requires third party to validate the transactions in the first place. Then easy transaction verification. Now if you have an issue, let's say you send someone money, you can easily trace it on the open public blockchain. You go and search, as you saw us doing in that video. We can see some people's transaction there. If same way, if I had conflicts, I send someone money, says he didn't see it, I can go to the blockchain and prove it. Yes, this is the transaction. What do you have to say? But for bank, I will have to request a bank statement, and sometimes some data are not updated on the bank statement, so the bank has to wait for some things to come up, and it's always a tedious process. When you talk about banking system, you always hear 3 to 5 days. That's their terms, okay? 3 to 5 days things, and 7 days, all those kind of things. So we all know all this now. So we have seen the differences and some of the similarities of crypto and fiat. Now the next thing is Bitcoin and blockchain. I earlier talked about that there are differences and there are similarities, and basically blockchain is the technology, Bitcoin is the implementation. So now Bitcoin and blockchain. Bitcoin is a decentralized currency. Blockchain is a distributed database. Okay, what does that mean? Blockchain is a distributed database. Bitcoin is a digital currency. It's just what I've been saying since the beginning of this video, so I don't think there's basically much thing I need to say about that again. We also have financial asset. It is tradable. Bitcoin is tradable. Blockchain is basically for recording information. Now this Bitcoin use what? It records the transaction information on what? The blockchain. So you see, Bitcoin is the implementation of the blockchain. We have first and most popular cryptocurrency. So we now see that this blockchain handles any kind of digital data, okay, and has several use cases. You can use blockchain apart from remittance. You can use it, but Bitcoin is only for remittance. Okay, you can't use Bitcoin for any other thing. Okay, it's only for remittance. Okay, it's only for other cryptocurrencies. Probably you see they allow smart contracts to be built on it, that is allowing extra functionalities from the blockchain to be done on it. Then we also have computer softwares. You can see various ways to build. Okay, and we also have it's an open source code, and we also have blockchain is the same thing. Blockchain is an open source code, and blockchain is a computer software as well. We also have is a public and decentralized currency. Bitcoin is a public and decentralized currency. Blockchain is a digital ledger. Okay, it's an open digital distributed ledger. So that is basically it on this video. I believe we've been able to get good intel or knowledge about Bitcoin as the first implementation of the blockchain technology. And I believe if you have any question, you can drop it on the comments. And if you believe this video can you want to request for videos, or you believe more things can be done on these videos, or more things can be explained on these videos, you can put in your suggestions on the comment section. Thank you for watching. See you in the next video.